Part 1. The first step into the quantum world. Amid the complexities of modern life, we seem to find an odd simplicity in the fundamental laws of the universe. Standing on a solid bridge, our hearts suddenly seem to touch a world where nothing seems to be surprising. This strong structure always supports us steadily, unwavering, while the stream of water below flows endlessly, following the unchangeable natural laws. When we throw a stone into the water, we know for sure that it will fall, as if destiny had predetermined it to fall into the water in perfect stability. All of this seems so obvious. The universe appears to have operated this way since time immemorial. Everything before us seems stable and trustworthy to such an extent that people rarely stop to ask themselves, could anything change? But then, a group of scientists began to raise questions. They sought to peer deeper into the microscopic world, the basic particles, the building blocks of everything. And in that world, in the tiniest of worlds, everything we once took for granted began to dissolve. Making room for a reality full of the strange, the illogical, and the impossible, disregarding all the rules we thought we understood. This was the quantum world, a place where mysterious and bizarre rules dominated, and all the principles we once knew turned out to be far from what we imagined. The story begins in Berlin in 1890, a period of brilliance and change, when the newly unified Germany had just become an ambitious industrial empire. The city of Berlin, during this time, became a center of creativity and development, where the first scientific and technological revolutions began. Electric lights illuminated the streets, a living symbol of modernization and hope for a bright future. The first electric light bulbs, invented by Thomas Edison, were not just sources of light. They symbolized advancement and the future. The German capital saw the birth of a new industrial age, with capitalists seizing the opportunity to invest millions of marks to purchase Edison's patents. But behind the bright lights, there remained an unsolved mystery. Despite the talents of engineers, there was one question they couldn't explain. Why did the color of light change when the temperature of the filament changed? The relationship between temperature and the color of light was a complete enigma, waiting for a brave mind to solve it. Soon, German researchers recognized that solving this mystery could open new doors to humanity's understanding and give Germany an advantage on the world stage. In 1900, the German government decided to establish the Physical Technic Research Institute in Berlin. With the goal of becoming the center for groundbreaking scientific discoveries. In 1900, they invited a young scientist full of potential, Max Planck, to join them. Planck, with his candid spirit and classic scientific method, was given the task of unraveling the mystery. Why does the color of light change when the temperature increases? The question seemed simple, but it was hiding an incredibly complex world. For Planck, this was not just an industrial problem, it was an opportunity to open a new era of knowledge for humanity. With a classic light bulb, as the temperature increases, the light becomes more intense, shifting from red to orange to yellow. But no matter how high the temperature rises, the light never turns blue. The strange thing was, no matter how high the temperature was, the light could never reach the color blue or violet. The relationship between temperature and the color of light was a mystery that scientists could not explain. This was when Planck, with his persistence and love for science, began his research. Planck built a special device, called a blackbody radiator, to precisely measure the colors of light emitted as the temperature changed. Through countless experiments and calculations, he discovered something odd. To explain this phenomenon, he had to accept a bold hypothesis: energy is not continuous but exists in small packages called quanta. This discovery, seemingly simple, opened the door to a revolution in physics, overthrowing all the old theories that SC. This discovery not only explained the change in light color but also opened up a new understanding of the universe. Planck's theory about energy quanta did not just solve the ultraviolet catastrophe but also laid the foundation for future research in quantum mechanics. An entirely new field of physics that humanity had not even dreamed of. When Planck announced his discovery, he did not know it would become the first step in a scientific revolution that would change everything humanity had once known about the nature. From Planck's discovery, other scientists, including Albert Einstein, began to dive deeper into the mysteries of the microscopic world. Einstein, with his sharp mind and intuition, formulated a new theory of light. He discovered that light is not just a wave, it can also behave like small particles called photons, each carrying its own packet of energy. This discovery earned him the Nobel Prize in Physics, but it was just a part of the long journey he was about to undertake. The story of quantum mechanics did not end with the discoveries of Planck and Einstein. It continued to unfold through the work of other great minds, such as Niels Bohr, who introduced the theory of uncertainty in quantum mechanics. Bohr believed that particles do not have a fixed state but only exist when they are measured. This was the key point that made Einstein, who always believed in an objective reality. to oppose Bohr's theory, sparking an endless debate about the nature of the universe. This debate led to new steps in understanding quantum mechanics, bringing up fresh questions about the nature of reality itself. Do the things we see really exist the way we think they do? And from here, a new world, one full of strange mysteries and surprises, began to unfold before human eyes. Since then, the quantum world has not just been a scientific field, it has been an endless journey, one that continuously challenges the imagination and curiosity of mankind. The story of quantum mechanics, with all its mysteries and wonders, continues to open new horizons for humanity, changing the way we perceive the universe and ourselves. Part 2: The Quantum Revolution. In the years following Max Planck's breakthrough, the scientific world stood at the precipice of a new and unprecedented era. What had once been considered the stable, predictable universe of classical physics was rapidly being upended. The discovery of quantum theory, although revolutionary, was merely the beginning of a series of profound shifts in our understanding of reality itself. At the heart of these discoveries stood one of the greatest minds of the 20th century, Albert Einstein. As a young man, Einstein had already shown signs of brilliance. And it was only a matter of time before his curiosity and passion for understanding the natural world would lead him to the frontiers of quantum mechanics. But where Planck had laid the first stones of quantum theory, it would be Einstein who would build the road that others would follow, revealing even deeper layers of the universe's mist. It was in 1905 that Einstein published his groundbreaking paper on the photoelectric effect, which would earn him the Nobel Prize in Physics. These particles, which he called photons, could carry packets of energy. This insight not only confirmed Planck's theory of energy quanta but also introduced the idea that the very fabric of light was not as straightforward as it had once appeared. It was. For Einstein, this discovery was just the tip of the iceberg. His work on the photoelectric effect was pivotal in the development of quantum mechanics, but it was also part of a much larger vision of understanding the fabric of reality. The more he delved into the quantum world, the more he realized that the very nature of reality itself might be in question. However, despite his revolutionary findings, Einstein remained skeptical about certain aspects of quantum mechanics, particularly the theory's inherent randomness. For him, the universe had to have an underlying order, one that was logical and deterministic. This skepticism would lead to some of the most famous debates in the history of science. One of the most intense and long-lasting debates in physics occurred between Einstein and Niels Bohr, another giant of the quantum world. Bohr, with his deeply intuitive understanding of quantum theory, believed that the universe was governed by probabilities, not certainties. To Bohr, quantum mechanics was a complete theory, one that explained the strange phenomena observed in the quantum realm. But Einstein, ever the realist, could not accept that the universe, at its most fundamental level, was ruled. The centerpiece of their debate was the nature of reality itself. Was the universe truly deterministic, as Einstein believed, or was it governed by probabilities, as Bohr argued? As these two brilliant minds clashed, the scientific community watched in awe. Their debates were not just about the minutiae of quantum theory, they were about the very nature of reality. Was the universe a machine, predictable and deterministic, or was it a chaotic and probabilistic system? Governed by the strange and sometimes bewildering rules of quantum mechanics. However, even as Einstein remained skeptical about some of the more bizarre aspects of quantum mechanics, his own contributions to the field were undeniable. His work on the photoelectric effect was pivotal in the development of quantum theory. And his theory of special relativity, which described the relationship between space-time and energy, laid the groundwork for much of the 20th century's scientific progress. While Einstein's theories were pushing the boundaries of relativity, another quantum discovery was quietly beginning to emerge. In the 1930s, scientists such as Erwin Schrödinger and Werner Heisenberg were exploring the behavior of subatomic particles in more detail. It was during this time that the idea of wave-particle duality became more fully realized. And Schrödinger introduced his famous thought experiment involving a cat in a box, a thought experiment that would come to symbolize the strange and Yet, despite the success of quantum mechanics in explaining the behavior of particles and energy, a lingering question remained. What did all this mean for the nature of reality itself? Was the universe truly governed by chance? Or was there an underlying order that had yet to be discovered? The answer to this question remains elusive to this day. Quantum mechanics, with all its strange and perplexing discoveries, has opened up new frontiers in science and technology. From the development of quantum computers to the understanding of the fundamental forces of nature, the quantum revolution has reshaped the scientific landscape. And yet, the nature of reality, what is truly real and what is merely an illusion, remains one of the most profound and unanswered questions in science. For now, we can only wonder at the strange and mysterious world of quantum mechanics, a world where particles can exist in multiple places at once. Where light can be both a wave and a particle, and where the very fabric of reality is shaped by probabilities and chance. The journey into the quantum world is far from over, and with every new discovery, we are drawn deeper into a universe that defies our understanding. The revolution of quantum mechanics has just begun, and humanity stands on the threshold of a new age of scientific discovery, one that promises to unravel the deepest mysteries of the universe. As we continue to explore this strange and wondrous world, we are reminded that the more we learn, the more we realize just how much there is still left to uncover.